welcome to the Data Science Salon webinar about unifying minds, unleashing the synergy between LLMs and knowledge graphs. And as we know, this is a really hot topic. Thank you so much for joining us here, and thank you so much, AringoDB, for being a sponsor for this one. For those of you who are new to Data Science Salon, welcome, and thank you so much for joining us here. My name is Anna, and I'm the founder, and Data Science Salon has been around since 2016, and the reason that DSS was born, it was really to create a vendor-neutral, diverse community. And that's what was done after my tenure at Domino Data Lab on the co-founding team. And 2016 is when DSS was born. And we've had over 1,000 events and webinars and probably more than 5,000 webinars now since we've been around, and we actually license our content to O'Reilly Media and other media outlets. So we've been creating a lot of it, and today we're really excited to dive into this topic. So I'm just going to go ahead and hand it over to George, and please enjoy the show. And if you'd like to collaborate with us or just say hello, our team is going to be in the chat today. And yeah, enjoy the show, and I'll see you around. Bye.
Hello and welcome. Thank you so much for joining today's webinar. And it's actually about two of my favorite topics, graph technologies, or in particular knowledge graphs, and machine learning, in particular large language models. And we will see how we can unify those two concepts and come up with a very powerful outcome. So what is this about? First, on the one hand, large language models. They have been all over the news, and I'm pretty sure all of you have tried ChatGPT, GPT-4, or a Llama model before. What is it all about? A large language model actually is capturing and large language, as the name suggests, and thereby allows us a natural language interface to general knowledge. When I first tried it out end of last year, I was really impressed what kind of questions I could ask, and you get like almost like a human-like output. If you ever came across like the notion of Turing test, I really felt like, hey, that could be passing the Turing test. Sometimes it was really hard to tell apart. But then on the other hand, there are also challenges with that where, for example, it wouldn't pass a Turing test. And in particular, that is the challenge of hallucination. When a large language model comes up with random facts which are actually not based on the original data it was trained on, and also which doesn't correspond to reality out there. And this is mainly due to that it has been trained on like on unstructured data, and therefore also gives us like probabilistic outcomes. The other world we're talking about here are knowledge graphs. So knowledge graphs, network of real-world entities and relationships between them. So they're really good at capturing domain-specific knowledge. If you ever came across a notion of semantic web, there are also versions, for example, of Wikipedia who represents the entire data in Wikipedia as such kind of knowledge graph, and then I can also query it in a structured form. Those knowledge graphs, they can either be private or could belong to a particular enterprise, and you might not even want to share that data out there. Or they can also be, as mentioned before, out there on the internet. So for example, semantic web, where it's really accessible for everyone. And then we can even combine multiple knowledge graphs into like one larger notion and combine knowledge out there. So what we can already see that those two concepts, they're really complementing each other very well. So knowledge graphs on the one side, they represent structured knowledge, custom data, so I can have my own data in there. But on the other hand, they're pretty hard to query. So I usually need like a domain expert going in there who can then retrieve information from those knowledge graphs. And they're typically incomplete. So there's only the data in there which has been put in there. Then, on the other hand, large language models, which we talked about first, they come up with a very native natural language interface. So I don't need any experts to query them. But on the other hand, they're missing that implicit knowledge. They're missing that custom knowledge. And also, they suffer from the challenge of hallucination, where I might just get random outputs, and therefore it's not really worth for me to pursue it further because I don't know whether I can trust the outcome. But if we combine both of that, and this is what this webinar is about, we can actually achieve a very powerful combination here. And this is where ArangoDB comes in. ArangoDB is an open source graph database. So we actually have especially built those knowledge graphs over the past years. But on the other hand, we also worked a lot in the graph analytics and graph machine learning. So if you want to learn more about that, just go to our website. We'll have links later as well. But in particular, that means we worked with large language models, and we also worked with other graph machine learning techniques for a long time. And this is why we actually believe the combination of both can really help us also being a graph database to provide the graph capabilities to a much larger audience out there. So if you, for example, building custom knowledge graphs, allowing access to non-experts, building a chatbot on your documentation, on your custom data for your homepage, and all that while avoiding hallucinations. Quickly to my background, I'm Jörg, I'm CTO here at ArangoDB. Prior to that, my background is mainly data and large-scale data analytics. So worked for a while at SAP, long time ago, did my PhD on distributed database systems, and in particular built a lot of machine learning and data analytics infrastructure across various companies. So let's jump back to how we can combine those worlds. There's also a very recent paper about it. I think it's from June this year. So if you're interested, the link is down here. And they identified three main areas how large language models and knowledge graphs can play together. On the one hand is during training of such large language models, we can provide structured knowledge. So we can actually not just provide like text, unstructured text, but a more structured knowledge if we have a pre-built knowledge graph during training. So this is what be here what's mentioned under one knowledge graph enhanced LLMs. Then the second part, and this is what we'll be mostly focused on, is LLM augmented knowledge graphs. So we want to basically leverage large language models to either query our knowledge graph or also for tasks such as completion or generation of such knowledge graphs. And then the third area there, touching up on this paper, is basically the kind of like entire combination where they just play like side by side next to each other, pretty much like combining the prior two approaches. So what does it mean if I now just come into that field? So let us start with unstructured data. So imagine you have some relational database systems or even data lake, or NoSQL database. So you got like your data somewhere, and now not those large language models, they can help us. What's here mentioned as step 2 to generate the knowledge graphs. Then we have a representation of those knowledge graphs. This would be here in the middle, would be ArangoDB in our example. And then the second, or here actually step 1 comes in. This will start out with that. This is then the retrieval and augmentation of such knowledge graphs. And this is also what we'll be focused on, because it will actually give the most benefit to probably the wider audience here. So what does it mean? If I go in and I have such knowledge graph, a knowledge graph usually consists of different entities. So for example, here we have a knowledge graph schema where we have a paper. The paper can have a relation to a title. So here, for example, has title. It can have a publishing here, papier here. It has an author. It can be published as a conference. So basically, it has like several kind of relations to other entities. And in particular, it can also have relations to the same type. So for example, one paper can cite each other. There's a wide range of different knowledge graphs out there. So for example, Google search is backed by a large knowledge graph. The Facebook even has a graph API to some of their knowledge graphs. The Amazon product graph is also out there. And then what I mentioned earlier, for example, DBpedia, kind of like the semantic web version of a Wikipedia, which represents most, let's just say most of the Wikipedia knowledge, such a knowledge graph, as you can see here on the right. Then what would be the status quo? Imagine you're in your company, you have an expert team who has built the knowledge graph for your company. So for example, here in this case, it would represent the entire network structure, all different kind of logins and all interactions with that network infrastructure. Now you have your team of business analysts, and they want to ask certain questions to that. So, for example, if we are now concerned with cybersecurity, you might be interested in particular with like, hey, is someone attacking my network? So, for example, has this particular network here been affected by like some certain malware? In the traditional world, as a knowledge graph is said, like someone has to go in and know how to access this knowledge graph. In traditional world, this would mean your business analyst with this question is now coming to the expert team and is like, hey, I would like an answer to that. So expert team will go in the ArangoDB case, write a certain AQL query, with other graph databases, write the particular other query out there. So, okay, we'll give that the answer back to the business analyst. Business analyst is going to look at the outcome. And in this case, it might be, oh, the network is infected. And this is basically when the business analyst will come up with the next question. So you already see this will not be a single question the business analyst needs translated by the expert team, but typically it's an entire conversation. And this is also one of the beauties for me for ChatGPT, that it actually allows you to have an entire conversation, even keeping context of your previous questions in mind while doing that. So just with this approach, when you always have to go to an intermediate who can kind of translate your questions to that particular knowledge graph, this will actually slow down the entire process. So will lead to long turnaround times, will actually really add burden to your expert team. And it's really hard to come up with like really quick interactive ways of also getting business outcome, which in this case would mean identifying new threats, communicating those new threats to their customers or to their internal teams. So how can we do that better? And this is exactly where we here at step one. And as mentioned, this is also why I wanted to start with step one, is that large language models can come in and basically translate those queries into the representative, in our case, AQL queries. But in general, basically, you don't need to have any graph knowledge, and you don't need to understand the underlying knowledge graph to answer your questions, because you can simply pose them in natural language here. So that was part one. And I think we'll see that later in the demo is already very powerful because it can enable a much larger team of non-expert users to leverage it. But on the other hand, if we quickly jump back here, there's also the step two. And this would be the question, how can we further enable our expert team to even be more efficient in generating this knowledge graph? Typically, such knowledge graph will be generated from multiple other sources. So as mentioned here, we can have relational databases, we can have other NoSQL database systems in the mix, we can have a data lake, or we can, for example, also simply have like a Kafka pipeline of like new inflowing data into the system. And this again is where large language models can now help us to parse this huge amount of unstructured data, text data, and turn it into a knowledge graph. So here on the right, we would have an example, and that could be, for example, the DBpedia use case. They take the text available on Wikipedia, and then the first thing you need to do when building a knowledge graph is extracting and identifying the different entities in your knowledge graph. So for example, here, that would be Barack Obama, that would be a particular location, Honolulu, that would be a country, United States of America, that would be a city here, and so on and so on. So first thing we can do with those large language models, we can identify the different entities in our unstructured data here. Second thing, and equally important, is then what is the relationship between those entities? So for example, Barack Obama was born in Honolulu. And I mean, if you now go to Wikipedia and look up the Wikipedia entry about Barack Obama, you'll see there's probably a sentence mentioning that. So a large language model can retrieve both entities from that sentence and then also extract the relation and creates this upper part here of the knowledge graph. There's more things we can do. So for example, a co-reference solution or even the end-to-end knowledge graph construction. I mean, in my experience, it's still helpful to have an expert team which kind of reviews that and kind of guides it. But I think also there we are getting better and better. As you can imagine, this is a very emerging field right now. The last thing, which can be quite powerful and can also be used for other tasks, is when we talk about text embeddings, which can be generated. If you ever looked at ChatGPT, GPT-4, they actually have a so-called embeddings endpoint. And what is this useful for? So, for example, our knowledge graph, as mentioned, it will never be fully complete. We will always miss certain relations, for example. So, for example, here, if we talk about Harry Potter, we want to figure out what kind of genre is that movie, or what kind of genre has J.K. Rowling been writing about. And we might not be able to find a sentence which says that directly, but we can still infer it from the overall knowledge graph. And this is then when we close a bridge to normal machine learning techniques. And in particular, this is then when those embeddings are becoming very useful. So those embeddings, they are basically this, it's a very fancy term for like a large sequence of numbers, or also referred to as a vector. So this is also why vector databases are currently like very, also on the hype curve, pretty much up there. And, but it's just a fancy name for a long list of numbers representing a certain entity. So for example, if we're talking about knowledge graphs, a knowledge graph, we want to represent each of those points here in our knowledge graph as a particular point in our vector space here, in our embedding space. And in this embedding space, we can then take certain tasks. So for example, we would expect that concepts which are close to each other in the real world, they're also embedded very close to each other. So we can, for example, do deduplication. If we have similar names for the same person, we would expect, as they always appear in the same context, as they appear in very similar spots in our overall knowledge graph, the embedding will be close to each other, and therefore we can use that for deduplication. We can also leverage that to find similar concepts or group concepts, cluster concepts in general, and then basically takes that knowledge back into our knowledge graph. So it's pretty much a cycle. We go from our knowledge graph into the structured embedding space. We can do certain tasks there, and then we can encode it back into our knowledge graph, and thereby, for example, do this task of knowledge graph completion, where we are missing certain relations in our knowledge graph. So how can the end-to-end picture look like? And then I promise we'll switch over also to a demo to see that in real-life action. So large language models can, first of all, help us to generate knowledge graphs, to basically extract the entities and relations from other data sources, which might be NoSQL, relational, data lakes, or even just a stream of data coming in. So this basically supports our expert team in building and maintaining this knowledge graph. Then on the other hand, there are the business users or end users even out there. They can be just leverage natural language to query this knowledge graph. So they don't have to know any of the intrinsics, any of the structure of the knowledge graph. They can simply pose natural language questions, and then this gets translated and basically answered against the knowledge graph here in the middle. So how can we do that in the end? So what we at ArangoDB have chosen is we made an integration available in LangChain. So LangChain is a framework for developing, I would call it like the Swiss Army knife of large language models. So first of all, you can build like chains of different requests. You can have different integrations to different data sources. So it's a very powerful tool set. And with that, we have integrated there, and I'll quickly show you then how we can leverage large language models to query our knowledge graphs here. As mentioned, ArangoDB is integrated into LangChain, so this is also a very easy way for you to just test it. There's an example notebook here. I kind of preloaded the notebook, so we can skip some of the setup steps, but it's the same as if you click here. So the other nice thing is ArangoDB is offering a very easy demo service, and this allows you to create temporary databases out here. So I already preloaded our Games of Thrones dataset here. It's a nice toy example dataset to explain what's going on, and as mentioned before, also share best practices around creating such integrations. But we'll switch to something more realistic later on using the cyber dataset we've seen earlier. Okay, so how does it look like in the database? I mean, we now just loaded some data, but we can actually go here as well. So here's just a link. So let's go here, and unfortunately need to copy as it's a temporary database, and I couldn't restore the username password. So let's quickly jump over here, log in, and select our database. So here, how ArangoDB is structured, we have different collections, and in particular, we got different Games of Thrones characters here. So Ned Stark, Catelyn, etc. As said, it's a very small toy data set for this example. And then we got relationships between those characters. Real-world knowledge graphs, they look much more complex. So often you have like hundreds of different entities or collections here. And we'll see that in just a bit. But for now, let's quickly switch back here. So we have loaded all of this, and now we can actually go through here. And I think I didn't hit something up here, so I think let's just run this and this. Sorry for that. That happens if you preload, but then we should be just down here with the questions as well. So here we just see our graph schema, and this is basically then what is fed to the large language model. So it can understand what data do we actually have and how does our data look like. And now we can switch, setup part is done, and we can switch to the actual querying part. So here from LangChain, as said, we have we can import our Rango graph QA chain, and then we can run certain queries on this. So for example, here, we now have the query, is Ned Stark currently alive? If we look back here in our characters collection, Ned Stark, it has a field whether it is alive, which is currently set to true. So if we do that, the chain, the large language model, will automatically generate the following query. We could simplify that potentially, but it actually gives us a real result, and then is even returning the finished chain out here. We can run the next query here. So how old is Arya Stark? And again, it will generate a query, it will take the result, and then again, turn that result into natural language. Okay, so that was so far pretty easy, as we are only querying like one fact from the database. Maybe to explain a little bit more what's happening in the background. So if, for example, the large language model first is coming up with a query which is not valid, there's actually an action which will catch that error and then generate like a next query, an improved AQL query with the error code we have seen before. So basically, the system can learn from mistakes it's doing, and so also technically improve over time if we keep the context around. But as I said, that was kind of like part one. So more interestingly, right now, I said we only focused on like individual characters, but right now, let's actually go in and see whether we can create and retrieve relationships from the graph. So for example, here are those two related? And we see this will generate already a kind of slightly more complex queries, still pretty easy, but it's a so-called graph traversal. So we are traversing the graph and we're kind of filtering whether there's like Ned Stark in our direct network. And we'll see how we can optimize that query a bit later. But again, we get a result and the large language model can understand that they are related and even tell us kind of the provenance of that they're connected through this child of relationships, and therefore she is a child of Ned Stark. Again, this is coming back to the schema information we have provided earlier, so the system actually knows what's going on. We can then ask even other queries. For example, are there any dead parents around? So for example, again, this is combining then two of these things we've done earlier, creating a graph traversal and checking for certain properties on those. Okay, great. So those systems work quite well out of the box. In my experience, it works even better if you do SQL generation, for example, because there's simply more examples around there. So when ChatGPT, GPT-4 were trained, GPT-4, by the way, also performs much better on those tasks. It simply has more information available to train itself. But we can actually help out the system. So what large language models are really great at is if I provide some either one shot or few shot learning examples. So for example, if I simply give it certain examples, which these are the same queries we've run before, but they kind of like simplified, right? This is now when the domain expert is going in and says like, hey, the query returned here is not optimal. We can actually improve that. So just by giving the chain some examples, and let me quickly run that, we can modify other parameters as well, but right now we mostly really care about those queries, and we will get hopefully a better result than before. Yes, we get from the database perspective a much more efficient query. If we look back up here where we run the same query, it generates like a very basic query. And here, with just a few examples you can provide, especially particular to your use cases, you can really improve the performance and overall performance of the system. And same here with our traversal queries, they can also be improved and not have the filtering we see here, which is a bit complex and also for humans a bit harder to read. So I think this is kind of like one of the key aspects. Like if you can just help the large language models with providing a few examples, you typically will end up with much, much better performance. What can that help us to achieve? I mean, running this here in the Jupyter Notebook is great, but in the end, we want to build real systems also on more complex knowledge graphs. And this is where, for example, here we have a cyber chatbot, and this is referring back to the use case we had earlier down there. And here I can now go in and, as a business analyst, basically just simply ask very simple questions. So, for example, here, what packages were involved in a particular trickbot intrusion, and then I get the output from the knowledge graph. I can also do more complex things or other queries like which protocols are being overall used on the network to kind of secure, know what do we have to secure, and we get a list output of that. So this can really help us then to provide easy to use interfaces to our knowledge graphs. And now if we quickly look here, as said, like I wanted to show a bit more complex knowledge graph. And so, for example, here, often we have like a much larger number of collections. So real world knowledge graphs, they're even more complex than our toy example there. So creating those queries is a bit more complex, but also alleviates more work from the experts out there. All right, with that, let's quickly jump back to our slide set here. So first of all, that was pretty much the content, so thanks for listening. And this actually opens us up for questions. So hopefully I can answer most of them. So please just submit them through the chat. And if you don't feel, or if you get a question after we've finished here, you can also just reach out either via rangodb.com or via our Slack community. As said, there's also a big community out there to answer questions, or you can also just use Twitter or any of your favorite social networks. So with that, thank you very much for listening, and let's switch over to the Q&A part.